Communicating with the server at present, the color organizer is rendering UI on the server and re-rendering UI in the browser. Once the browser takes over, the organizer functions as a single-page application. Users dispatch actions locally, the local state changes, and locally the UI is updated. Everything is working well in the browser, but the dispatched actions are not making it back to the server. In this next section, we will not only make sure that this data gets saved on the server, we will make sure that the action objects themselves are created on the server and dispatched to both stores. Completing actions on the server in the color organizer, we will integrate a REST API for handling our data. Actions will be initiated on the client, completed on the server, and then dispatched to both stores. The server store will save the new state to JSON, and the client store will trigger Jira UI update. Both stores will dispatch the same actions universally. Fig 1202. Figure 12-2. Creating a universal action. Let's take a look at an example of the complete process for dispatching an add color action in the proposed solution. 1. Dispatch action creator add color with new title and color. 2. Send data to server in new post request. 3. Create and dispatch the new add color action on the server. 4. Send the add color action in the response body. 5. Pass the response body and dispatch the add color action on the client. The first thing that we need to do is build the REST API. Let's create a new file called .src/server/color-API.js. Every action created is handled the same way. It is dispatched on the server and then it is sent to the client. Let's create a function that dispatches the action to the server store and sends the action to the client using the response object. Const dispatch respond equals res action equals rec.store.dispatch action res.status 200.syn action. Once we have an action, we can use this function to dispatch the action and send a response to the client. We will need to create some HTTP endpoints using the Express router that can handle various HTTP requests. We will create routes to handle GET, POST, PUT, and delete requests on the route/API/colors. The Express router can be used to create these routes. Each route will contain the logic to create a different action object and send it to the dispatch respond function along with the request and response objects. Import router from Express. Import v4 from UID. Const dispatch respond equals res action equals rec.store.dispatch action res.status 200.syn action const router equals router router.get/colors res equals res.status 200.synrig.store.getState.colors router.post/colors res equals dispatch respond res. Type add color, ID v4, title rec.body.title, color rec.body.color. Timestamp new date.toString. Router.put/color/ID, res equals. Dispatch respond res. Type rate color, ID rec.params.id, rating parsintrigue.body.rating. router.delete /color/ID, reg, res equals. Dispatch armed respondreek, res. Type remove color, ID rec.params.id. Export default router. Each function added to the router object handles a different request for http://local. Host 3000 /API/root. Get /colors. Response with the current color array from the server state. This route is added just so we can see the listed colors. It is not used by the front end. Post /colors. Creates a new color action object and sends it to dispatch armed respond. Put /color/ID. Changes the rating of a color. The color's ID is obtained from root parameters and used in the new action object. Delete /color/ID. Removes a color based upon the ID sent in the routing parameters. Now that we have defined the routes, we need to add them to the ExpressApp config. Duration. First, we install the Express body parser. npm install body parser. Save the body parser is used to parse incoming request bodies and obtain any variables sent to the routes. It is necessary to obtain the new color and rating information from the client. We'll need to add this middleware to our ExpressApp configuration. Let's import the body parser and our new routes into the ./server/app.js file. Import body parser from body parser. Import API from ./color API. Let's add the body parser middleware and the API to our ExpressApp. It is important to add the body parser before the API so that the data can be parsed by the time the request has been handled by the API. Export default express. .use logger. .use file assets. .use body parser.json. .use add story to request pipeline. .use /API. .use match routes. The body parser.json is now parsing incoming request bodies that have been formatted as JSON. Our color API is added to the pipeline and configured to respond to any routes that are prefixed with /API. For example, this URL can be used to obtain the current array of colors as JSON http://localhost 3000 /API/colors. Now that our ExpressApp has endpoints that can respond to HTTP requests, we are ready to modify the front-end action creators to communicate with these endpoints. Actions with Redux Funcs. One problem with client/server communication is latency, or the delay that we experience while waiting for a response after sending a request. Our action creators need to wait for a response before they can dispatch the action, because in our solution the action itself is being sent to the client from the server. There is middleware for Redux that can help us with asynchronous actions. It is called Redux Func. In this next section, we will rewrite out action creators using Redux Func. These action creators, called funcs, will allow us to wait for a server response before dispatching an action locally. Funcs are higher-order functions. Instead of action objects, they return other functions. Let's install Redux Func. npm install Redux Func. Save Redux Func is middleware. It needs to be incorporated into our store factory. First, at the top of ./src/store/index.js, import Redux Func. Import func from Redux func. The store factory has a function called middleware. It returns the middleware that should be incorporated to the new store in a single array. We can add any Redux middleware to this array. Each item will be spread into the arguments of the apply middleware function. Const middleware equals server equals server. Server logger client logger func. Const store factory equals server equals false. Initial state equals. Apply middleware server create store. Combine reducer scholars, initial state. Export default store factory. Let's take a look at the current action creator for adding colors. Export const add color equals title, color equals. Type add color, ID v4, title, color, timestamp new date dot to string. Store dot dispatch add color jet, 000000. This action creator returns an object, the add color action. That object is immediately dispatched to the store. Now let's look at the func version of add color. Export const add color equals title, color equals. Dispatch, get state equals. Set timeout equals. Dispatch. Type add color, index get state dot colors dot length 1, timestamp new date dot to string. Title, color. 2000. Store dot dispatch add color jet, 000000. Even though both action creators are dispatched the exact same way, the func returns a function instead of an action. The returned function is a callback that receives the store's dispatch and getState methods as arguments. We can dispatch an action when we are ready. In this example, a set timeout is used to create a 2-second delay before we dispatch a new color action. In addition to dispatch, funcs also have access to the store's getState method. In this example, we used it to create an index field based upon the current number of colors in state. This function can be useful when it is time to create actions that depend upon data from the store. Not all of your action creators have to be funcs. The Redux func middleware knows the difference between funcs and action objects. Action objects are immediately dispatched. Funcs have another benefit. They can invoke dispatch or getState asynchronously as many times as they like, and they are not limited to dispatching one type of action. In this next sample, the func immediately dispatches a random rating started action and repeatedly dispatches a rate color action that rates a specific color at random. Export const rate color equals ID equals. Dispatch, getState equals. Dispatch type random rating started. Set interval equals. Dispatch. Type rate color, ID, rating math.floor math.random 5. 1000. Store.dispatch. Rate color F9005B4E9753D A64679DF172E1DBB. These funcs are simply samples. Let's build the real funcs that the color organizer will use by replacing our current action creators. First, we'll create a function called fetchNDispatch. This function uses isomorphic fetch to send a request to a web service and automatically dispatch the response. Import fetch from isomorphic fetch. Const parse response equals response.json. Const log error equals console.error. const fn dispatch equals dispatch, URL, method, body equals fetch, URL, method, body, headers content type application /JSON, dot then parse response, dot then dispatch, dot catch log error. The fn dispatch function requires the dispatch function, a URL, the HTTP request method, and the HTTP request body as arguments. This information is then used in the fetch function. Once a response is received, it will be parsed and then dispatched. Any errors will be logged to the console. We'll use the fn dispatch function to help us construct funcs. Each func will send a request to our API, along with any necessary data. Since our API responds with action objects, the response can be immediately parsed and dispatched. Export const add color equals title, color equals, dispatch equals. fn dispatch, dispatch, /API /colors. Post, json.string for title, color. Export const remove color equals ID equals, dispatch equals. fn dispatch, dispatch, /API /color /ID. Delete. Export const rate color equals ID, rating equals, dispatch equals. fn dispatch, dispatch, /API color /ID. Put, json.string rating. The add color func sends a post request to http //localhost 3000 /API /colors along with the title and hex value of the new color. An add color action object is returned, parsed, and dispatched. The remove color func sends a delete request to the API with the ID of the color to delete provided in the URL. A remove color action object is returned, parsed, and dispatched. The rate color func sends a put request to the API. The ID of the color to rate is included in the URL as a root parameter, and the new rating is supplied in the body of the request. A rate color action object is returned from the server, parsed as JSON, and dispatched to the local store. Now when you run the application, you can see actions being dispatched to both stores in the console log. The browser console is a part of the developer tools and the server console is the terminal where the server was started. Figure 12-3. Figure 12-3. Browser console and server console. Using funcs with WebSockets, the color organizer uses REST to communicate with the server. Funcs can also be used with WebSockets to send and receive. WebSockets are two-way connections between the client and the server. WebSockets can send data to a server, but they also allow the server to send data to the client. One way to work with WebSockets and funcs is to dispatch a connect action creator. For example, let's say we wanted to connect to a message server. Store.dispatch connect a message eSocket. Funcs can invoke dispatch as much as they want. We can create funcs that listen for incoming messages and dispatch new message actions when they are received. This next sample uses socket.io client to connect to a socket.io server and listen for incoming messages. Import IO from socket.io client. Const connector socket equals dispatch equals. Dispatch it connecting. Let socket equals IO / message socket. Socket.io connect equals. Displative connected, ID socket.id. Socket.onMessage, message, user equals. Displative new message, message, user. X4 default connector message eSocket. As soon as the connector COP socket is invoked, a connecting action is dispatched. We then attempt to connect to the message socket. Once connected, the socket will respond with a connect event. When this happens, we can dispatch a connected action with information about the current socket. When the server sends new messages, message events are raised on the socket. We can dispatch new message actions locally every time they are sent to this client from the server. Funcs can work with any type of asynchronous process, including WebSockets, Socket.io, Firebase, set timeouts, transitions, and animations. Just about every React application that you build will require the existence of some type of web server. Sometimes you will only need a web server to host your application. Other situations require communications with web services. And then there are high-traffic applications that need to work on many platforms that will require different end solutions entirely. Advanced data fetching. If you are working on high-traffic applications that share data on multiple platforms, you may want to look into frameworks like Relay and GraphQL or Forecore. These frameworks provide more efficient and intelligent solutions for providing applications with only the data that they require. GraphQL is a declarative data querying solution developed at Facebook that can be used to query data from multiple sources. GraphQL can be used by all types of languages and platforms. Relay is a library, also developed at Facebook, that handles data fetching for client applications by linking GraphQL queries with React or React Native components. There is a bit of learning curve associated with GraphQL and Relay, but it is well worth it if you really like declarative programming. Forecore is a framework developed at Netflix that also addresses issues associated with fetching and efficiently using data. Like GraphQL, Forecore allows you to query data from multiple services in a single location. However, Forecore uses JavaScript to query data, which likely means less of a learning curve for JavaScript developers. The key to React development is knowing when to use the right tools. You already have many of the tools needed to build robust applications in your tool belt. Only use what is needed. If your application does not depend upon a lot of data, don't use Redux. React State is a great solution that is perfect fit for the right size app. Your application may not require server rendering. Don't worry about incorporating it until you have a highly interactive app that has a lot of mobile traffic. When setting forth to develop your own React applications, we hope that this book will serve as a reference and a great foundation. The React and its related libraries will almost certainly go through changes. These are stable tools that you can feel confident about using right away. Building apps with React, Redux, and functional, declarative JavaScript is a lot of fun, and we can't wait to see what you'll build.